Hello friends, welcome back. Hearty welcome to you. Let us try to solve some problems related to trigonometry. So let's go ahead and try to solve them. The first one, what is the value of 32 cos to the power of 6x minus 48 cos to the power of 4x plus 18 cos square x minus 1 divided by 4 sin x cos x sin of 60 minus x cos of 60 minus x sin of 60 plus x into cos of 60 plus x whole thing is equal to how much? Now these type of problems, unless you solved them earlier, never try to attack them because they are called as spoilers. They will take lot of time and you will be ending up spending more time than what is needed. So sometimes we have to be careful to see which problems to leave or which problems to take them. This problem, if you look at NCERT 11th class textbook and some other books, you know that these are all different types of problems. 3 problems are clubbed into this. So let us try to separate the 3 problems. Then we know the solutions for all the 3. We will be getting our solution. So first I'll write down the numerator part. What is there in the numerator? 32 cos to the power of 6x minus 48 cos to the power of 4x plus 18 cos square x minus 1. The whole numerator is equal to cos of 6x. You can try that out. You can do apply by cos of 2 into 3x you can do, or you can do cos of 3 times of 2x. So here you will be applying formula for cos 2 theta. Here you will be applying formula for cos 3 theta. You can check that the whole numerator part is equal to cos 6x. Now let's come to the denominator and separate them into 2 different parts. One, I will keep the 4 as it is. First I'll write down all sine terms. They will be sin x into sin of 60 minus x into sin of 60 plus x. Again, this is a standard problem. Sin of x into sin of 60 minus x into sin of 60 plus x is 1 by 4 times of sin 3x. That's a standard problem. One more standard problem coming, that is cos x into cos of 60 minus x into cos of 60 plus x. This is equal to 1 by 4 cos 3x. Now let's go ahead and substitute them. We will have numerator, as we said, cos 6x, and the denominator we have 4. Then I said that multiple of all the sine related is 1 by 4 into sin 3x. Similarly for the cos it will be 1 by 4 into cos 3x. Let us simplify that. We can cancel 4 and 4 and this 4 will go up to the numerator part. We will have 4 cos 6x divided by sin 3x cos 3x. But if we look at our solutions or options, we have all in terms of 6x and they are cot tan. So what we will do, we'll multiply with 2 and 2 in numerator and denominator so that we can write it as 8 cos 6x divided by, in the denominator we have 2 sin theta cos theta, which is equal to sin 2 theta. So that will become 8 cot 6x. Again I repeat, if you did not see this problem earlier and for the first time you are taking it, just take a wild guess. Never try to solve this type of problems because this takes lot of time. So if you have gone through the NCERT and other textbooks, then you know that all this problem is nothing but numerator part is a separate problem, denominator is combination of 2 problems. All these solutions you keep and try to simplify them, you get 8 cot 6x. Let's go to the next problem, which seems to be little bit more easier. Let's look at the next problem. What is the value of 2 cot? That is pi. So 2 cot pi minus a divided by 2 divided by 1 plus tan square 2 pi minus a divided by 2. Let us simplify this. we will have 2 cot pi by 2 minus a by 2 divided by 1 plus tan square pi minus a by 2. Let's go to the next step. We know cot of 90 minus theta is tan theta here, and we know tan of pi minus theta is minus tan theta, but we are squaring up. So it will become tan square theta here, and here it is tan theta. So let's go ahead and write down that. That will be 2 tan a by 2. That's equal to 2 tan a by 2 divided by 1 plus tan square 180 minus theta is tan square theta only. So can I write down tan square a by 2. Now what is 1 plus tan square theta, which is equal to secant square theta. So can I write down 2 tan a by 2 by secant square a by 2. Let us simplify that, convert them into sine and cos. We will have 2 sine a by 2 by cos a by 2, and secant square a by 2 when it comes to numerator will become cos square a by 2. So can we simplify that and write it as cos a by 2 into cos a by 2. Now 1 cos a by 2 will cancel. You get 2 sin a by 2 cos a by 2, but that is equal to sin a, because we know that sin 2a equal to 2 sin a cos a. Submultiple angle sin a equal to 2 sin a by 2 cos a by 2. So the solution is sin a. Next one, we have tan theta plus secant theta, or can I write it as secant theta plus tan theta? Secant theta plus tan theta is equal to x minus 2 divided by x plus 2. Now we have to find out the value of cos theta. What is the easiest way to solve this problem is, we know that secant square theta minus tan square theta equal to 1. That means secant theta minus tan theta will be reciprocal of secant theta plus tan theta, that is x plus 2 divided by x minus 2. Now let us try to sum this up. We can cancel tan theta. We get 2 secant theta is equal to x minus 2 divided by x plus 2 plus x plus 2 divided by x minus 2. Let us simplify that. We'll have 2 secant theta equal to, in the denominator we have x square minus 4, and in the numerator we have x minus 2 whole square plus x plus 2 whole square, which is the formula for a minus b whole square plus a plus b whole square. So can I go ahead and write down 2 secant theta is equal to 2 into x square plus 4 divided by x square minus 4. 2 will cancel out. We have secant theta equal to x square plus 4 by x minus 4. We know cos is reciprocal of secant. So cos theta is equal to x square minus 4 by x square plus 4. Let's go to the next one. What is the value of cos 40 minus cos 140? Let me write down cos 40 minus cos 140 divided by sin 80 plus sin 20. Looking at the problem, we know that we have to apply transformations. So before that, what I will do, I'll write down cos 40 minus cos 140 as cos of 180 minus 40, and then I will do transformation sin c plus sin d. I will have 2 cos sin, right? First will be sin 2 sin c plus d by 2, that will be 80 plus 20 by 2, and multiply that with cos of 80 minus 20 divided by 2. Let's go to the next step. In the next step we will write down, you know cos of 180 minus theta is minus cos theta. So can I write down cos 40 plus again cos 40, because cos of 180 minus 40 is minus cos 40, minus of minus is plus, and we have sin 50 in the denominator, with us also is cos 30 degrees. Now let's try to simplify that. That will be equal to 2 into cos 40 degrees divided by 2 into sin 50 is nothing but sin 90 minus theta. Can I write it as cos 40 again? And cos 30 degrees. 2 will cancel, cos 40 cancels. That is nothing but 1 by cos 30. We know cos 30 is root 3 by 2. So 1 by root 3 by 2 equal to 2 by root 3. So our solution is 2 by root 3. The second one, not the first one. 2 by root 3 is our solution. So if you think that too much trigonometry, let's do one interesting geometry problem and close this session. So we'll do one very interesting geometry problem. Let's go there. In the given figure, PQRS is a square whose side is 8 centimeter. PQS and QPR are two quadrants. A circle is placed touching both the quadrants and the square as shown in the figure. What is the area of the small circle we have there? We have to find out the area of the circle. That means we have to find out the radius of the circle. Let us say the radius of the circle is r. Now what is the concept we are going to use to solve this problem? This problem may be solved in more than one method, but the method which I thought or found it to be easy is we'll use the concept of whenever two circles touch with each other externally, then the distance between their centers C1 C2 is equal to sum of their radii. Now what is that I am talking about is, if you take this as center P and draw a circle, draw a big circle, and similarly take center and draw another big circle, then what you see is the distance between P to the center of the circle will be 8 plus R, because we know PS equal to 8. That means radii of the quadrant is 8. So 8 plus R, we have a isosceles triangle. So we'll try to divide the square into different parts and sum the area equated to 8 by 8, which is equal to the square of the, which is equal to area of the square. So from that we should be able to find out our R. So let me go ahead and try to join P to the center of this P and Q respectively to the center of the circle. So we have divided the square into different parts here. One is the right isosceles triangle, then we have two right angle triangles, then we have a rectangle. All these areas should add up to 8. So let's try to find out these individual areas and sum them and equate it to 64. So I'll write down one by one the areas what we have to find out. The first will be the area of the isosceles triangle, and for the triangle we have the sides, equal sides are 8 plus R, R being the radius of the small circle, 8 plus R, and this side is 8. Then we know area is given by half into base 8 into height h. H is given by square root of, by Pythagoras theorem we'll have 8 plus R whole square minus 4 square, because we know this distance is equal to 4. Let us simplify that. We will have 4 into root of 8 plus R whole square minus 16. That is the one part of the square. The second, we have two triangles which are right angle triangles. These two triangles we are talking about, right angle triangles with one side 4 and another side equal to 8 minus R, and their area is given by half into 4 into 8 minus R, and we have two of them. So 2 will cancel, we get 4 into 8 minus R. We also have a rectangle at the top in green color whose length is given by 8 and the width is given by R. So the total area is 8 into R. Now this total area of all these parts should add up to 8 into 8, 64. So let's write down that. At the top we will write it down so that we can erase this. 4 into square root of 8 plus r whole square minus 16 plus 4 into 8 minus r plus 8r is equal to 64. Now we have to solve for the value of r. Let's go ahead and do that. In the next step, we'll try to divide with 4. We will write down square root of 8 plus r whole square minus 16 plus 8 minus r plus 2r is equal to 16. Let's simplify that. We will have 8 plus r whole square minus 16 equal to 16 minus 8, that is 8 minus r. Let us square it on both sides. We call it as sobs. Let us do sobs. When we do squaring on both sides, we'll have 8 plus r whole square minus 16 equal to 8 minus r whole square. Now we have an algebraic formula. A plus b whole square minus a minus b whole square is equal to 4ab. Can we apply that? 4 into 8 into r equal to 16 or r equal to 1 by 2. Now once we know r equal to 1 by 2, area of the circle is given by pi into r square, which is 22 by 7 into 1 by 2 into 1 by 2. Can we simplify that? And that will be equal to 11 by 14 cm square. So what's our approach to solve this problem? Let's have a recap. We have been given that there is a square and we have two quadrants, one with center as P and one with center as Q. So we know radii of this quadrant is equal to the side of the square, 8 centimeter. Now there is a circle which is touching both the quadrants and also the side of the square as shown in the figure. We have to find out what is the radius of that small circle. So what we have done, we know that the concept we used is the distance between centers of two circles touching each other externally is sum of their radii. So we have r here, we have 8 plus r, 8 plus r. We have one isosceles triangle, two right angle triangles and one rectangle. All these are involving with variable r, and the area should be equal to sum up to area of the square 64. So we kept that condition, we solved for it and we found out r equal to 1 by 2. Therefore area equal to 11 by 14 cm square. So those are some interesting problems which I just thought of sharing with you. Thanks for your time and support. I'll catch you once again with some more interesting examples. Till then, keep smiling and sharing. Have a wonderful day wherever you are. Bye for now.